Hey guys, I just wanted to share something with you real quick that I discovered that I thought was really cool.
Hello there, Skeptic Squids. Welcome to Experimental Woo. Angelove again has something exciting to share with us. It would be rude of me to keep you waiting, so let's hear what she has to say.
I actually did see a video on YouTube regarding this, but I wanted to share it with you because I was making orgonite.
Wait, did she just say orgonite?
Making orgonite.
She did say orgonite. What exactly is orgonite? According to the website organizeyourself.com, yeah, I know, the person who came up with that pun probably feels super clever. Orgon is a substance made from resin that contains metals, stones, and quartz. It's supposed to balance and harmonize your bioenergy, or orgon. It's sometimes also called chi or prana, or whatever floats your boat, I guess. Apparently the benefits of orgonite are limitless. This includes, but not limited to, helping you sleep at night, improving your spiritual and mental growth. It helps you stay immune to certain diseases. It helps protect you from electromagnetic fields. It also improves your mood, makes you feel more energetic, and it can even help you with love, or so I'm told. If you would really like to know more about orgon and orgonite, I suggest you go watch Oskar video on the matter. He makes a better video, more in depth. I'll link it in the description and put one of those card things up here somewhere.
I wanted to know if my little tiny pieces of Shungite would do this. So anyways, I have a digital multimeter.
Well, I mean, I got like 1, 2, 3 multimeters, and including an isolation tester, so I don't think you can beat that.
And basically, Shungite does conduct energy.
Hold on there. What do you mean the object can conduct energy? This makes no sense. An object can possess energy, albeit potential, kinetic, thermal or chemical energy. It can either then transfer this energy to a different object, or the energy it possesses can transform into a different form of energy. For instance, chemical to thermal energy. Then again, I'm using the scientific definition of energy. I have no clue it is what your definition you're using.
And I wanted to show you proof of this by using a digital multimeter. And in this mold, I'm making some EMF protection pendants.
EMF protection pendants? She's talking about electromagnetic fields. I'm pretty sure she has no idea what she's talking about. That little object of hers does not contain any field of its own to block other EMF fields. If it did, it too would have an EMF field, which according to her is harmful. Look, if you really want to protect yourself from Wi-Fi signals, just get yourself a Faraday cage.
And they're also psychic protection.
Psychic protection? Well, good. I'm gonna need one of those next time I venture into the zone.
And inside of here is Shungite, Amazonite, and labradorite. And basically, here's the digital multimeter. So when I take these two pieces that are hooked up and I hold them up to the Shungite rock, you're going to watch the digital multimeter and you're going to see that, oops, here, I'm going to go to this one because it's closer. You're going to see that it registers some numbers when I touch the rock, and that is showing that it does conduct energy.
I've been avoiding explaining what Shungite is for a reason. We'll get to that. First, if you inspect the video, you'll see she's using a multimeter set on the ohm scale to measure the resistance of the rocks. She's also failing to get good readings, as some of the readings are actually her just touching the two probes together, and the mineral or rock in this case is also covered with a bit of resin, which would obviously make taking a measurement difficult. Okay, I can hear you guys asking me now. Purple Dan, what is Shungite even? Shungite is elemental carbon in a non-crystalline form. Shockingly, it's conductive.
Now, when I touch a different rock, like Amazonite, it's not going to move because the Amazonite doesn't conduct energy the same way that the shungite does.
Well, of course the other rocks are not electrically conductive like the carbon is.
And what's really cool is these are really tiny pieces. I mean, these are maybe like 6 millimeter chips, and you can see that they're registering some pretty good numbers. All these black chips that I'm touching are shungite. So, in all honesty, I don't know what the numbers mean.
As absurd and funny it is that she has no idea what's going on, I do still have some respect for her, because she's being completely honest. Angel Love, if you're actually watching this by any chance, the next part of the video is specifically for you. You have set the multimeter on the ohm scale. You're measuring the electrical resistance of the material. If you correctly apply the probes to material and the multimeter, in your case reads 1, it means open circuit. There is no current flowing from one probe to the other, and thus the material is electrically non-conductive. If you do get a measurement, the material is conductive and current is flowing from one probe to the other. The value you get is resistance, measured in ohms. You see, a multimeter works by putting a known potential across 2 points, the difference in potential is known as voltage, and measuring the current that flows between these 2 points. We can then calculate the resistance using a special case of Ohm's law. Voltage is equal to current times resistance. Making resistance the subject, we get resistance equals voltage divided by current. Obviously, voltage and current is known, so we can calculate the resistance. If the 2 points have no potential difference, they are referred to as being electrically common. In this case, there is no resistance between the 2 points. If there is a potential difference and current flow, it means there is a voltage drop, and therefore resistance between the 2 points. Lastly, if there is a potential difference and no current flow, you're measuring an open circuit, or an infinite resistance. So now we know how a multimeter measures electrical resistance. But what is electrical resistance anyways? Electrical resistivity is a property of a material that quantifies how strongly the material opposes current flow. The dimensions of a material is responsible for its total resistance. Let's inspect some minerals and materials of our own to assess whether they too can, conduct energy. Metals have more free-flowing electrons and therefore are more electronically conductive than materials that have little to no free-flowing electrons. We can actually test this property by measuring some minerals and some rocks, and then going on to measure some source of water, going from extremely pure water to salt water. So here we are at the workbench. We have the trusty Fluke 117 ready to measure the resistance of the minerals I have here. We have some minerals like amazonite, galena, pyrite, and among a few, and we'll be measuring which of these will conduct electricity or conduct energy. We start off by first putting the multimeter on the ohm scale, and we'll measure some amazonite. To no surprise, it doesn't conduct any electricity. It's non-metallic. The same goes for andesite. Nothing. Some chalcedony. Nothing. And some rose quartz. Again, nothing. You'll notice that the multimeter says OL. It simply means open loop, i.e. no current is flowing through the probes. We'll then test some metallic minerals, such as galena. Galena is a lead ore. It's a lead sulfate. Measuring it from end to end, we get 4 ohms. We can turn it around, measure it again from end to end, and we get, it's a bit fluctuating there. Of course, it would fluctuate if we put it on some lead oxide. It will definitely change, but put it on the clean piece of lead, you'll notice that the resistance drops down to about 2 ohms. So, quite obviously, this mineral is conductive. Here we have some pyrite. And it too is conductive, although it has a way higher resistance. Right now, if it goes through the little oxide layer it's formed at the surface, you get around 37 ohms. And it's also fluctuating wildly. It's very difficult to get a good measurement on these minerals since they're obviously not polished clean and they have an oxide layer growing. So you have to kind of dig the probes into them first before you get a good reading. Scratching the probe on the surface will clear off the oxide layer quite well. And there we go. We again get a measurement of 33 ohms, which is to expect. Here again we have some pyrite. Pyrite is actually iron sulfate, also known as fool's gold. So it's also a metallic mineral. Over here, once going through the oxide layer, we get around 114 ohms, which is pretty good. Turning it around, measuring from a different place, we're getting 400 ohms. The resistance will obviously change the farther apart we put the probes. And here is a quite difficult one. It's a polished piece of hematite. You can measure it, although it's quite difficult. You have to be quite careful. Yeah, this is gonna take a while. Finally, I get a measurement on it of 4.4 megohms. Yeah, it's a conductor, although an extremely high resistance conductor. I expect the same from Shungite. I don't actually have a piece of Shungite, unfortunately, so I can't directly test it, although I suppose it would be sort of similar. What I can test, however, is a piece of graphite. Since Shungite is just elemental carbon, a piece of graphite will do just as well. Measuring it from end to end, we get a nice 18 ohms, which is good enough. Here's just a tweezer, just made out of some high carbon steel. Measuring that, we get, if we just again make sure it makes good enough contact, we get 20 kilo ohms, which is what you can expect from steel, which is, well, rusted. Here we're going to measure the resistance of various water sources using the Fluke 117 and the Fluke 77. Using two multimeters will give us a more accurate result. We'll just average the two. We're going to start from the cleanest source of water being the ionized water, moving down to more contaminated sources. The idea behind that is that if we do contaminate our probes, we do not contaminate the cleaner source, instead add contaminants to the more dirtier source, so any contamination would be negligible. Here's a chart I made using the data. I sorted the data using the Fluke 77 as a reference because it seemed to be the most reliable. The chart plots the conductivity of the water against the water source. Conductivity is measured in Siemens. The y-axis is logarithmic to make the data more visible. A clear trend is seen with the water containing the least amount of free electrons, being the deionized water, being greatly less conductive than the water containing the most free electrons, in this case being salt water. My hypothesis was correct, however there are some inconsistencies. I expected the rainwater to be less conductive than the tap water, because the tap water contains chemicals such as chlorine. However, the Fluke 117 agreed with me, the Fluke 77 did not. I suspect the inconsistencies are due to the leads themselves. One set of leads might be a different length than the other set of leads, and also the probes themselves differ quite a bit. The Fluke 77 has more surface area than the Fluke 117. These sort of things will definitely affect the measurement. Even just the simple oxidization on the probes themselves will cause a difference. The experiment can be improved greatly by first of getting a proper lab ohmmeter and then getting probes that's gold coated.
But I do know that that definitely means that that shungite is conducting energy. And see, if I touch these other stones, any other stone that I touch, the multimeter does not move. But as soon as I go to the shungite, bam, it moves. So I just wanted to share that with you guys. I thought it was pretty cool, and I like to share things like that because I'm a see it, believe it when I see it kind of person, and I think shungite's an awesome stone to include in my orgonite. So anyways, if you have any questions, feel free to ask. Thanks for watching.
You're saying that, however you don't use that same train of thought to prove whether or not orgonite has any substantial effect on you. There are so many videos out there that can be debunked by simply doing experiments such as these. Not even that difficult experiments, I don't even have the proper equipment to do them properly, but I can still manage to disprove them. Of course, I hope you guys enjoyed watching these experiments as much as I enjoyed doing the experiments, and thank you for watching thus far. Next video is gonna be back to the roots, where it all started. Most probably young Earth creationism, most probably Kent Hovind. Although no promises, it might be some other funny guy like Walter Brown or Dr. John Baumgartner, whatever his name is. We might even go there. Again, thank you so much for watching, and it will be awesome if you can give me some feedback in the comments below regarding the experiment. Do you like the way it was done? Do you like the way it was presented? And yeah, do you like this sort of videos? Because that always helps. If you don't like the video, you have to tell me. Anyways, enjoy the rest of your days, guys. I just said enjoy the rest of your days. Enjoy the rest of your days. Enjoy the rest of your day. There we go. Fine.